Hello my dear students, welcome to computer science class. Let us continue with our chapter input, output and memory devices. So in our previous video class we had started with a discussion of secondary memory storage devices. So herein what is the main purpose of using secondary memory devices are they provide the backup storage wherein we can store the data permanently, okay, and use it for the later purpose, and we can use this secondary storage devices in order to transmit the data from one computer system to the another computer system, okay. And some of the examples of secondary storage devices are hard disk, magnetic tapes, floppy disk and the CD-ROM. So in our previous video class we have seen what is a hard disk. Hard disk was a kind of magnetic disk wherein we could store the computer data. It's a kind of direct access storage medium wherein we could access, that means wherein we could store and retrieve the data randomly. Then we had a discuss about magnetic tape. Magnetic tape is a kind of it's a strip of plastic wherein it is being coated with a magnetic recording medium, okay. So herein the magnetic tape is a kind of serial access medium wherein we are unable to access the data, we are unable to store and access the data randomly. Now in today's video class we shall discuss about the floppy disk. As you can see here the image, the floppy disk drive uses a thin circular disk for the data storage. You can see this is a floppy disk, okay. It uses a thin circular disk for the data storage. It is a soft magnetic disk. You can see here inside this, okay, disk, it is a outer coverage actually, okay. This is inside it we are having a soft magnetic disk within it, and it is a thin magnetic coated. It is a magnetic coated disk contained in a flexible or a semi-rigid protective jacket. Actually within this floppy disk there is a very soft magnetic disk is being placed within into it, and this magnetic disk is being contained in a semi-rigid protective jacket. What you can see, the black color, that is actually the outer jacket that is protecting that soft magnetic disk. Like how for the hard disk we are having the the magnetic disk we are having, the same way for the floppy disk within it we are having a soft magnetic disk, okay, that has been coated with a thin magnetic, okay, medium, and it is protected by the protective jacket. Now this disk, whenever you place the floppy disk, it also actually rotates at 360 rotations per minute, okay. It will be rotating around 360 rotations per minute, and here also we are having the read or read head that make a physical contact with the disk surface. Whenever we request for the read or the write operation, actually the read or write head will make a physical contact with that particular disk by reaching to the particular track, and again the tracks are being divided into sectors. So the read or write head will reach to that particular location, okay, and then the contents will be read from that. So here also the data has been recorded in terms of tracks. You can see here, okay, where the tracks are subdivided in the form of sectors. So usually the floppy disk are 3.5 in size, 3.5 inches in size, okay. However, older floppy disk we had in terms of 5.25 inches also we had, okay, or even 8 in size. So usually the standard one what we were having was 3.5 floppy inches floppy disk, which could hold at least 1.44 megabytes of data. So herein how once the data has been stored onto the floppy disk, it could be write protected. So write protected in the sense what, where you cannot make the modifications. You can write the contents once, you cannot allow anybody to make the modification. So once your floppy disk is write protected, it prevents any new data being stored or any old data being erased. That means you cannot make any kind of modifications. So usually in order to have this floppy disk, okay, the disk drives for the floppy disk are being used. They are called as floppy drivers. See, whenever you place a floppy disk onto your computer system, okay, the floppy disk has to be detected by your computer system, and it will allow you to access to read and write the contents to this floppy disk. For that we need the floppy drivers. So earlier computers had the provision of having the floppy disk, okay, and we were using the floppy drives in order to detect this floppy disks. So floppy disks are quite slower in order to access the contents, in order to store the contents when we compare it to the hard disk, and they will have very less storage capacity. As I said, so the 3.5 inches floppy disk can hold around 1.44 megabytes of data. So their storage capacity is quite less, but it is very less expensive, okay, and it is portable. So this is one of the external storage, storage device wherein you can, by using the floppy disk, you can transmit the data from one computer system to the another system. It offers the portability. And here the contents could be accessed randomly. That means what? You can store and retrieve the contents randomly. Therefore, the floppy disk is a direct access storage medium. I hope the concept is clear. So I'll just summarize in short. Floppy disk is a kind of circular disk. Okay, can you see here? It's a kind of circular disk which has been placed in a semi-rigid protective jacket. It has been coated with a magnetic medium. So this disk also rotates like how the hard disk will rotate. Around there, and it rotates around 80,000 rotations per minute. So here it is taking around 360 rotations per minute. So if at all, if I want to read the contents from the floppy disk, again we need to make use of the read or write head. Here also the data has been stored in terms of tracks. Tracks are subdivided into sectors. Okay, usually the size of the floppy disk is 3.12 inches. We are having 3.5, 5.25. So the up to 8 inches also the floppy disk were being available. Okay, so herein it's a floppy disk is a kind of we can make it as write protected, wherein it will prevent any kind of data being stored or added, or any old data getting erased. Nobody will have that permission once if it is a write protected. Alright, in order to have the floppy disk, we have to have the floppy drives. Okay, and it has a very less storage capacity and has the portability, and it is very less expensive too. Alright, so this was all about the floppy disk. Now let us discuss about the optical disk. So optical disk, these are the storage medium from which the data could be read and to which the data could be written by the laser. This is what is optical disk. Can you see here? Okay, you can see here with the help of laser, actually the contents are being written in the sense where the contents are being stored onto the disk. Read in the sense whatever the contents are being stored onto the disk, we can read it, either it is audio file, video file, or any text file, or any kind of document it might be. Okay, so the optical disk is a kind of random access storage medium. Random access means by now I hope you are able to get an idea what is random access and what is serial access medium. Random access means so you can store and retrieve the contents from any location. You can from any location you can play the contents, if it is an audio file or the video file or any kinds of file it might be. So therefore the information could be easily read from any point onto the disk. So herein the CD-ROM stands for compact disk read only memory. Okay, here in the CD-ROMs the tracks of information could be written onto them by the user actually. So they are being called as read or write CD-ROMs. That is, here the data has been in terms of, placed again in terms of tracks. Can you see here? This is one track. This is the second track. This is third track. This is fourth track. Here also the data has been stored in terms of actually the tracks by using the read or the write head. Alright. So usually we also have the read or write CDs also. We are having rewritable CDs. What you can see, CDRW means rewritable CDs we are having. Now let us discuss in depth what is this optical track, how the data is being stored onto this optical track. Alright, so see here. Yes, see, optical track is a kind of recording unit onto the data on the disk. See here, this is actually one track, students. This is one track, this is second, this is third, fourth, fifth, like that. So these are the recording tracks, in the sense these are the recording channels. So usually the information stored onto the CD-ROM is being arranged according to certain rules here. So how exactly these tracks are being formed, how the information is being stored onto these tracks means, see, whenever there is a formation of these kinds of tracks, the information onto the CD-ROM, while we are storing the information, they are being stored according to certain rules here. Okay, and herein the track is been actually in the form of what? Spiral shapes, okay, which wherein we refer it as an optical track, or we can even refer it as a light rail. See, whenever we actually store the information, initially the table of contents is being recorded into the starting address of the optical track. See, whenever you place a disk onto your hard disk, whenever you want to play the contents from your CD, okay, so when you just open your CD, open your driver there, CD driver there, when you open your computer system, first thing is you can see the contents. You want to play the movie or you want to play the songs. When you click on to play songs, you will get some songs, maybe 10 songs are there, all the list. So what exactly these are? These are the table of contents. Okay, usually like how when we open our textbook, we first have the table of contents. Based upon that, you are choosing certain page number, which chapter you want to see for. Based on that page number, you are being opening that particular page. Similarly here also, how these actually the information being stored onto the compact disc is, it is based upon the rules. What is that rule? Rule says that firstly you need to record the table of contents at the starting address of this particular disc, it says. Alright, so herein the audio CD in a song is been corresponding to the light rail. See, optical track, this is, as I said, it is for one optical track. These optical tracks can also be referred as an light rail, which are in the spiral shape. The one audio song in this particular CD is been corresponding to a light rail. So therefore in this we can have many number of light rails we can have. So usually the earlier the CD-ROM would have almost 99 in number as the light rail. See, whenever we actually come on to the particular any of the track or the light rail we have, the minimum length that has been required to get to this particular light rail is indicated by 4 seconds or 300 characters. Minimum each optical track requires the minimum length of each optical track should be at least up to 4 seconds it should have, or it should in each optical track at least it should have at least 300 characters. So this value what we are having, we can refer it as a threshold. I repeat, so herein the minimum length to traverse to this particular each track, it should at least take 4 seconds, or it should in each optical track at least there should be 300 sectors it should have. Okay, so this value we refer it as threshold. Suppose if the optical tracks with the minimum length, if it is not 4 second, okay, if it is less than the 4 second, okay, then it has to be considered as the bad optical track. Then that particular light rail we refer it as a bad optical tracks. Now you can see here, these are the depression part. Can you see? These are the depression part, and what here you can see, that's a flat surface, isn't it? The depression part onto this optical track is called as information pit. That means here the information is there. Okay, the land part, the flat part, we actually call it as that is land. I repeat, the depression part of the optical track is called as information pit, and the flat part here we call it as the land. So both the pit and the land are used to record the information onto your optical track. Alright, so at the time of burning, the burning in the sense, right, at the time of recording or at the time of moving the contents onto your compact disc, we call it as the burning. So when during burning, the CDR, that is compact disc read only, it will be read by using the organic laser irradiation, as I discussed. So herein we are able to record the data. We are able to record, that means the contents could be written or read by using the laser beam, isn't it? So in compact disc read only, we are using the the organic laser irradiation in order to form this kinds of bubbles. So this is the pit actually. Once the bubbles have been formed, we are unable to restore the status back again. Therefore, the CDR, that is compact disc read only, can be written only once, but you can read the contents many times. That is what is the all about the optical track. So herein we should just remember optical track is a kind of recording unit onto the disc. Okay, so herein whenever we are writing the contents, actually it is based upon certain rules wherein the table of contents have been recorded at the starting address of the disc. Each one of the song is been corresponding to one light rail. So therefore in one compact disc we can have many such light rails. Alright, the minimum length that has to be taken to traverse the entire light rail or the each optical track is about 4 seconds. If it or 300 sector, if it is less, then we can say it as a bad optical tracks. So at the time of burning, actually there is a formation of pit and land. So pit actually refers to the information and the flat surface actually refers to the land. So both the pit and PIT, the pit and land, are being used to record the information onto the optical track. By using the laser irradiation, there is a formation of bubbles onto this compact disc. So once the bubbles have been formed, we cannot retain the status back again. So therefore the compact disc read only can allow you to write the contents only once and you can read the contents several times. I hope you are able to understand. So here you can see this is the 8-bit data, 14-bit data. Okay, you can see here pit onto the disc. This is a flat surface. So once after the burning, there is a formation of the pit here. This actually represents the information. Again there is a flat surface, that is land, again the information. So this is how exactly the optical track will look like. I hope the contents are the concept is clear. Now let us discuss about the DVD. DVD actually stands for digital versatile disc. So it is also called as optical disc technology. So with the advances with the digital, that is a digital versatile disc, it can store the video program, music, data. Alright, so the CD-ROM, that is compact disc read only, is being referred to as the digital versatile disc. Next we are having the Blu-ray disc, that is BD. I think DVD So we have a DVD up to around, you can store the data in terms of GB, like 4.7 GB. In terms of DVDs are available with the storage capacities of in terms of gigabytes, whereas in case of compact disc they are available like 700 MB. Okay, so like 800 MB. We are having the different storage capacity. Obviously CD will have the less storage capacity comparatively to the DVDs. We have the DVDs player. We have a DVDs players in order to play the DVD. DVD stands for digital versatile disc. Like next we are having the Blu-ray disc. So this Blu-ray disc can also be referred as BD disc. Now here you can see the BD disc. Okay, see this is what is Blu-ray disc. Usually it is having the thickness around about 1.1 millimeter of recording layer. Okay, and it is having a transparent protective layer, okay, upon this, like how the compact disc we are having the direct laser beam. If you are able to hold your compact disc to the sunlight, if you are able to hold slightly, you can see the tracks, actually you can see it. So it doesn't have any protective layer, but here in case of Blu-ray disc, if you observe, it is having a very thickness of 0.1 millimeter transparent protective layer it is having. Then what will be the capacity of this Blu-ray disc is around 23.3 GB or 25 GB or 27 GB. So very high storage capacity this we can have the Blu-ray disc. So these are all the different kinds of secondary storage devices. Next we shall discuss about the portable storage devices. So what is this portable storage? We can also refer it as an PSD. the portable storage device, they are the small hard drives. You can see these are external hard drives. HDD hard disk drive. This is a flash drive. All right. That's your pen drive. Okay, that's your flash drive you can have. Then you can have a secure disk. Okay, USB floppy disk. Okay, universal serial bus USB stands for. All right. So these small portable devices, they are the small hard drives that has been designed to store or hold any kind of digital data, wherein the data is in terms of zeros and ones. Okay, so herein the portable storage devices, hard drives may come around 256 GB, 320 GB, 500 GB, or 1 terabyte or 2 terabyte. In terms of terabytes, we may get the hard disk. Okay, we may get the hard disk. So when these are portable storage devices are useful, these are useful whenever you travel. So when traveling, these PST will be useful. They'll act as an alternative to get the backup. Okay, and then you can have the memory cards. Secure disk is the memory card. Since if you are unable to have all these, you can have a small memory cards that which can hold the data into it. Okay, so if you are unable to download, if you don't have any computer to download something, then by using your memory cards, you can just plug into to the specific device, then you can get all the content. So some of the examples of the portable storage devices are hard disk drive, floppy disk, pen drives. Okay, these are few of the examples. So mainly these portable storage devices will help you to carry or to transfer the data from one system to the another system, okay, during traveling. I hope therefore they provide they offers the portability, wherein the hard disk at least can contain the data in terms of GB or in terms of terabytes. All right, now let us move on to the last topic of your chapter, that is cache memory. Very important. Cache memory is a very high speed memory that has been present between the primary memory and the processor. See, always I said whenever the CPU is executing, okay, during the processing, the CPU always fetches the data from the main memory. So main memory is having the random access memory or the read-only memory. Two types we are having, isn't it? Always the CPU will fetches the data contents from the random access memory. So this cache memory, it is a very small amount of high-speed memory that is present between the primary memory, which is also been referred as main memory, and the CPU, which is we also call it as processor. So herein we are actually having two levels of cache memory, that is L1 and L2. L1 is a type of cache memory. L2 is again a type of cache memory. L1 is a kind of cache memory that has been placed within the CPU itself. L1 is a cache memory that is being placed within the CPU. What all CPU consists of? CPU consists of the control unit, the ALU unit, and then it also consists of the internal register. So this L1 is a cache memory that is present within this processor itself. L2 is the cache memory that has been present onto the motherboard. Actually, this is entirely the motherboard. Here you can see here. This is the motherboard. Onto the motherboard, we are having the processor, that CPU. So within this processor, we have the L1 as a cache memory. Onto the motherboard, we have the L2 as the cache memory. So all these are being responsible to transfer the data between the different devices over the motherboard. All right, so what kind of information this cache memory can hold? The cache memory can hold the most recent data or the instructions that the CPU will have. See, we do also have the level 3 cache memory. Level 3 cache memory, the modern computer system, all we are coming with the L3 cache memory. But earlier we had only the two types, L1 and L2. For your discussion, we have just L1 and L2. Just remember, L1 is a cache memory that is present within the CPU. L2 is the cache memory that has been present on the motherboard. And L3 is being coming with the recent modern computers. Alright, so whether it is L1, L2 or L3, different kinds of cache memory, they are the very high speed memory which are responsible for transferring the data between the CPU and the other components of the computer system. Then what kind of data the cache memory is holding? The cache memory holds a very recent data or the instructions. Now listen here. See, whenever the CPU requires any data for the calculation purpose, the cache is usually filled from the main memory. Okay, see, the main memory, the random access memory will fill it will send more amount of memory to the cache memory. So the cache memory is usually filled with more amount of memory. So whenever the instructions or the data that are being required by the CPU will fetch all these data or the instructions from the that is from the main memory through the cache memory. So often the main memory will supply the wider amount of data to the cache memory than the CPU. See, suppose if any 2 or 3 different operations are being there for the CPU to execute, so that time what happens, this main memory will send a wider amount of data to the cache memory. It may send all the 3 processings, whatever the 3 different processing it has to perform at that time, it will send all the 3 different operations to be performed to the cache memory. The required data it will send, the data and the instructions. So this cache memory will provide only the first operation to the CPU for the processing purpose. So once that is been done, again the data will be sent to cache. Cache will send the final result to the main memory. Again the cache this time, by the time meantime the first final result reaches to the main memory, by the meantime the cache memory will send the second operation for the CPU for the processing. Similarly, by the time the output reaches back again to the main memory, because final output has to first reach to the main memory, then from main memory to the output device, isn't it? So again second one will be forwarded. Similarly, third one will be forwarded. So herein often the main memory will supply a wider amount of data to the cache memory than the CPU, so that the cache memory will rapidly provide the data transfer between the CPU and the main memory. The more the faster your data transfer is, the more the faster the CPU will process the data or the instructions. The more the CPU will process its data or the instructions, the more the performance of your computer system. So this is about the cache memory. And again herein the amount of information that replaces at one time into the cache is being called as line size for the cache. I repeat here, at once, okay, the amount of information at once it is being replaced into the cache, we actually refer it as the line size for the cache memory. So usually the width of this particular data bus, so this is bus is what it is, as I said, they are the two-way data channel that will help or responsible for the data transfer between from the CPU to the various components of your computer system. So the CPU is one of the component of our system. The memory unit is one of the component of our computer system. So what we are using here, we are using the data bus, isn't it? See, usually the amount of data will be sent according to the width of this particular data bus which has been present between the cache memory and the main memory, isn't it? The data bus is being placed between the cache memory and the main memory. The how much amount it is sending the data according to the width of this particular data bus. I repeat, a wide line size for the cache, or the line size of the cache, that actually refers to what? The amount of information that has been placed onto the cache at once. Okay, see, a wide line size for the cache, that means several instructions or the data words are being loaded into this cache at one time. So by using the width of the data bus which has been placed between the cache memory and the main memory. So this is all about the cache memory. Very important here. So the cache memory is a very small amount of high speed memory that has been placed between the primary memory and the processor. So we have two levels here. Just remember about the two levels. L1 and L2. L1 is placed within the CPU, L2 is being placed onto the motherboard. Okay, so both, what kind of information they are holding? The recent or the data or the instructions that are being required by the CPU for the processing purpose. So CPU will fetch all those data or the instructions from the main memory through the cache memory. Alright, so often the main memory will supply the wide amount of data into the cache memory comparatively to the CPU. The amount of memory that has been loaded into the cache memory at a one time is called as line size for the cache, or you can even say it as a wide line size for the cache memory. Alright, so a very important question on this cache memory, that is, what is cache memory? Or you may also, that is for 1 marks question. Frequently asked question is, what is cache memory? Or they may ask you to write a short note on the cache memory. So these are the very important questions. And then they also will ask for the here in the recent concepts what we have discussed about the secondary storage devices, write a short note onto the hard disk. Okay, and write a short note on the optical track, or short note on magnetic tape or the floppy disk, or would abbreviate PST, that is a portable storage device. Okay, abbreviate DVD, Blu-ray, okay, BD disc. Okay, so how many types of cache memory are there? So these are the few questions that you expect from the secondary storage devices. I hope the concept is clear. So this completes the chapter, that is input, output and memory devices. Thank you students. Take care.